Hello everyone, and welcome back to my YouTube channel. In this video, we'll dive into an essential topic in SQL, constraints and indexes. I will walk you through these concepts step by step. If you're new to these terms, don't worry. I'll break them down in simple and easy to understand language. So, let's dive in. Let's start with SQL constraints. Constraints are like the rules or conditions we set on columns in a table to ensure data validity and integrity. In simple terms, they make sure the data we store is accurate and reliable. Without constraints, there'd be no way to enforce things like unique values or mandatory fields. If a constraint is violated during a record action, the action is aborted. You can apply these constraints when you create a table using the create table command or modify an existing table with alter table. When creating a table, you define constraints directly in the create table statement. The syntax looks like this. Here's the basic syntax for creating constraints during table creation. There are 7 major types of constraints in SQL. First up, not null. This ensures a column can never have a null value. It's perfect for fields like email or username where you must have data. Next is unique. Every value in this column must be one of a kind. No duplicates allowed, ideal for IDs or emails. Third, the primary key. It's a combo of not null and unique. It uniquely identifies each row in a table, your go-to for the main identifier. Then there's the foreign key. It creates relationships between tables by referencing the primary key in another table. Think of it as the glue holding your database together. Fifth, the check constraint. It ensures values meet a condition. For example, setting a rule like age must be greater than 18. Next is default. When no value is specified, this provides a fallback. For instance, setting a default status of active for new users. Last is index. It's like a fast-forward button for your queries, helping retrieve data quickly and efficiently. Let's break all of them down one by one with examples for each. First up is the not null constraint. The not null constraint enforces a column to not accept null values. It ensures that every field must always contain a value. Without not null, a column can hold null, meaning no value is required. But with not null, you must provide a value. No empty or null entries allowed. When you insert or update a record, SQL won't allow you to leave the field blank. You must always provide a value. Let's look at an example where not null is used to enforce this rule. This SQL code creates a student table where ID, first name, and last name fields cannot be null. Every student must have an ID, first name, and last name. Let's say you try to insert a new student, but you forget to provide a first name or last name. SQL will throw an error because not null enforces that a value is required. However, once you provide the necessary data, like an ID, first name, and last name, it works just fine. That's the power of not null. This guarantees that you can't leave the ID, first name, or last name blank when inserting data into this table. Now you know what not null is all about. It keeps your data clean and ensures that every field has a value. Easy to implement, but very useful. Next is the unique constraint. Unique is similar to primary key, but with some key differences. Both constraints guarantee uniqueness for columns or groups of columns, but primary key includes unique by default and also automatically makes the column not null. A table can have multiple unique constraints, but only one primary key constraint. Unique constraints are great if you want to ensure no duplicates without making the column the main identifier. Let's take a look at an example where we use unique. In this example, email is unique across all records. No two students can have the same email address. Let's say we try to insert a student with a duplicate email. SQL won't allow it because of the unique constraint. It prevents any repeated entries in that column. However, if the email is unique, the record will insert successfully, thanks to unique. And now you know how unique works. It keeps your data clean and ensures no duplicates in important columns like email or usernames. Now, let's talk about the primary key. One of the most essential constraints in database management. It's what uniquely identifies each record in a table. The primary key constraint combines 2 important rules, not null and unique. Together, they ensure that each record has a unique identifier and that no 2 rows have the same value in the primary key column. A table can only have one primary key, but it can consist of a single column or multiple columns. This is known as a composite primary key. It's made up of two or more fields. Primary keys must contain unique values and cannot contain null values. Every record must have a value in the primary key columns. Let's start with an example of a single column primary key. In this example, ordered is the primary key. It uniquely identifies each order. Ordered must have unique values and null isn't allowed. Now, let's take a look at an example where we use a composite primary key. It's made up of two columns. In this table, ID and last name together form the primary key. No two records can have the same combination of ID and last name. Note: if you try to insert a record with a duplicate primary key, for example, the same ID and last name, SQL won't allow it because the primary key enforces uniqueness. On the other hand, if you insert values where ID and last name are unique, it will work perfectly, thanks to the primary key. So, primary key ensures that every record is uniquely identified and prevents duplicate entries. Now, let's talk about foreign key, one of the key concepts for establishing relationships between tables. It allows you to link tables together, making your database more structured and efficient. A foreign key is a column or set of columns in one table that refers to the primary key in another table. It helps create relationships between tables by matching data in one table to data in another. Foreign key is also referred to as a referencing key. Let's say you have two tables, courses and students, and you want to link students to their enrolled courses. The course ID in students serves as the foreign key, referencing the course ID in the courses table. Let's break this down with an example. Here's a simple relationship between courses and students. In this setup, students.coursed is the foreign key that references courses.coursed. This establishes a relationship between the two tables, ensuring students are enrolled in valid courses. Here's another example where a foreign key is linked to a customer table and an orders table. In this example, orders.id is a foreign key that references customer ID. This ensures that each order is linked to an existing customer, maintaining referential integrity. If you try to insert an order for a customer that doesn't exist, SQL will throw an error because the foreign key ensures only valid references are allowed. However, if the customer already exists, the order will insert successfully, thanks to the foreign key. So now you know how foreign key works. It helps maintain relationships between tables and ensures that your data remains consistent. Let's move on to the check constraint. The check constraint is used to limit the range of values that can be placed in a column. It ensures that any value entered in that column satisfies a specific condition. This could be on a single column or even across multiple columns within a table. A check constraint restricts the allowable values by enforcing conditions, such as numeric ranges or specific patterns. For example, it can ensure that a column only accepts values greater than 18 or valid email formats. Let's take a simple example to show how check works. In this example, the check constraint is applied to the age column. It ensures that age must be greater than or equal to 18. No exceptions allowed. Trying to insert a record with age less than 18 would be blocked by SQL because the check constraint enforces the condition age greater than or equal to 18. And that's how the check constraint helps ensure your data meets specific rules. Let's talk about the default constraint, one of the simplest yet very useful tools in SQL. It allows you to set a default value for a column when no value is provided. The default constraint in SQL automatically provides a default value for a column if no other value is specified during data insertion. It ensures that every new record gets a fallback value if one isn't provided. The default value will be added to every new record if no value is explicitly specified for that column. This is perfect for fields like status, created at, or active, where you want a standard value unless otherwise defined. Let's see how default works in practice. In this table, status has a default value of active. Every new student record will automatically have active set unless another status is provided. If you insert a new student and don't specify the status, SQL will automatically fill it with active, thanks to the default constraint. However, if you explicitly provide a different value, like inactive, SQL will use that instead. The default constraint only kicks in if no value is given. Now, let's talk about indexes, an important tool that can make your database queries run faster. An index in SQL is a database object that helps speed up data retrieval. It acts like a pointer or lookup table that allows the database to find the data faster without scanning the entire table. When you query a table, indexes prevent the need to scan through the whole table. Instead, the database uses the index to locate the data more efficiently, making your queries faster and more efficient. Indexes are especially useful for large tables where frequent searches happen. They speed up queries by narrowing down the search and reducing table scans. Just remember, index updates take more time than updating tables without indexes. So use indexes wisely on frequently searched columns. Let's see how you can create an index. In this example, we create an index called IDEXLASTNAME on the last name column in the persons table. This index will speed up any queries that search for people based on their last name. A query on last name without an index would have to scan the whole table. But with the index, SQL can locate the data much faster, thanks to the pointer that the index provides. If you frequently search or filter by last name, creating an index will improve the performance of those queries. And that's how indexes can make your database queries faster. Use them wisely on columns that are heavily searched. Here are some key takeaways from my video about SQL constraints and indexes. And that's a wrap. We've covered all the major SQL constraints: not null, unique, primary key, foreign key, check, default, and even indexes. These constraints are crucial for ensuring your data is valid and your database operates smoothly. If you found this video helpful, please like the video and subscribe to PyBrain for more SQL tutorials. If you have any questions, leave them in the comments below. Thanks for watching and see you in the next video.